Hello, everybody. My name is Andrei Azarov, and today I'm going to tell you about the new features that we've introduced into Aura 2.1. So before I start, I want to tell you that if you have any questions, please write these questions to the chat, and I'll answer all questions after I'll finish my presentation. So let's begin. So Aura Premium has 3 new features. The first one is, okay, so my colleagues told me that we can wait for a couple of minutes before we start, and because we should have some more people. Okay, now we are ready. Let's go. So in our Premium, we have 3 main features: masks, support blockers and enforcers, and CLI or command line interface. So one of our main values is to provide a flexible and open system to our users. And unfortunately, this flexibility usually comes together with complexity. As you may know, one of our products, NanoG Code, allows to fully control the reinforcing trajectories, the fiber trajectories, but it's not so easy to use. And with these new features in Aura, we are going to simultaneously provide flexibility and simplicity. And using these features, you can have a lot of control on the fiber trajectories, on the part internal structure in a user-friendly manner. So let's go to these features. The first one is masks. So what is the mask? The mask is an additional model that you can add alongside with your main part model. And this model allows you to change locally the slicing settings. For example, if you have a part with a mask and this mask intersect with your main model, you can change infill density, infill type, number of perimeters, etc. in this intersection. And this allows to have different properties, different structures in different volumes of your part. 2 types of masks are available: internal masks and full masks. Internal masks are somewhat similar to the layer structure scheme that we had before in Aura that allowed to change the part structure for different layers of the part. And full masks behave somewhat like a separate model, and full masks additionally allow to change the number of external shells and the number of top and bottom solid layers. But I'll show you a few examples so you will understand it better. So next thing is support blockers. Support blockers allow you to prevent the generation of support structures under the surfaces that are inside this support blocker volume. So Aura uses an automatic algorithm to calculate volume of support structures based on overhang angle or overhang distance. But in some cases, you need to prevent support generation in some area, or maybe to force support generation. So support blockers and enforcers allow you to do all these things. So this is information about support enforcers. In contrary to blockers, they force the generation of supports under the surfaces that are inside the support enforcer volume. And the last one is command line interface, or CLI. So it's a more specific feature, and it allows you to automatically generate G-code without user interface, without UI. So this can be useful if you have a lot of models and you want to slice these models with predefined settings. And as you have a lot of models, you want to do it in an automated manner. For example, if you generate some parts or some samples programmatically, you can use this Aura CLI to make G-code out of your model and slicing settings. The models can be in STL or step format, and slicing settings are in JSON format, and you can export slicing settings from Aura using main menu. And after that, you run Aura CLI and get G-code that is ready for printing. So that was a very brief overview of these features. And now let's go to the demonstration. So I'll start with masks. So let's open a model. For the demonstration, I have this model which represents the logo of Aura. And the best way to apply the mask to a model is to draw this model together with its masks in some CAD program and save it to step file, so that when you open the file, you will have several parts inside your step file as a separate models. And the relative positions of this part and mask models will be retained. So you will you have an ability to fully prepare your model in your favorite CAD program and then just import it into Aura and use this. So how to make this model a mask? To do this, you can select this mask model and then press the Set Mask button on the panel, on the models panel. Or you can use Edit Set Mask in the main menu. So let's press Set Mask. And after that, we can choose our base model, either in the list or in the viewport. So now this second model became a mask. So, but I don't see it, and to turn on the mask visibility, I can use this mask visibility tool on our new viewport panel. And by the way, our 2.1 has not only premium features, but some other features as well. One of these features is this view control panel. So now I can clearly see the mask and the main model. They became transparent. And if you have several mask models, for example, if I'll copy this mask, it will have some other color. So basically, if you have several masks, they will differ by color. After that, you can translate, rotate, transform, and manipulate the mask the same way as you can do for the main model. But if you want to translate or rotate the main model, the mask that is attached to this model will be moved as well. So for example, our logotype is in wrong position on the build plate, and I want to rotate it by 180 degrees. I'll apply it, and you can see that the mask retained its relative position to the base model. And of course, the main thing that we want to do with mask is to set up a separate internal structure inside this mask. So usually the structure of the part is specified by the settings that you set up on the slicing panel or in the profile. So, for example, here you have smooth PA plus continuous carbon fiber profile, and for the main model we can turn off all reinforcements, and we can go to the mask settings. You can open mask settings by clicking on this expander, and in this settings window you can set up a separate settings for the mask volume. For example, I can turn on reinforced perimeters, and I want to have, for example, 20 outer reinforced perimeters. And let's look at the slicing result. So, as you can see, we have fiber, which is colored with blue, and this fiber is following the contours of the mask, not the contours of the main model. So you can set up some settings for the mask, and the settings will be applied to the slicing. And what if I want to add another mask? What will happen if I have several masks? I can open another model, and for example, this is a second model. I will make it a mask, and you can see that we have an intersection between the mask and the rectangle mask, green one, and the logo mask, yellow one. And the order in which the settings will be applied depends on the priority. So currently, I have a rectangle with the first priority. So this mask will be applied first. And after that, the remaining volume will be used for the second mask. For example, if I want to have just plastic grid infill in this green volume and fiber reinforced perimeters in yellow volume, the result will look like this. So you can see that mask with the first priority overlap the mask with second priority. And if I will change the priorities, this can be done with these arrows. Then you can see that the mask with reinforced perimeters are prioritized now, and the second mask has the second priority. So another thing that I want to show you is the difference between the full masks and internal masks. So when I have this rectangle as an internal mask, that means that this mask share external shell and top and bottom solid layers with the main model. So as you can see, the external shell for the mask and for the main model is the same. But if I'll turn this to full mask, I can additionally specify number of external shell perimeters and number of top and bottom solid layers. And this way, you can see that now these models have separate external shells. And moreover, if I'll turn all code, I'll see that basically this mask volume doesn't have top and bottom solid layers as I've selected in the slicing settings. So here are the result. Okay, so now let's go from this simple sample models to something more complex. So what parts can you make with the masks? So let's start with a sample bracket. So this is a wall bracket, which is fixed in two upper holes. And this bracket is loaded with a vertical force. So what is the common approach to reinforce such a part? The first thing to try is to use reinforced perimeters. For example, I turn on reinforced perimeters and will use like 5 outer reinforced perimeters, and I'll generate the code. So as you can see, we have fiber going around the outer contour of our part and also around the inner contour. The problem is that the loaded hole is connected to the fixed holes only through a plastic infill. And it's not very effective in terms of strength and stiffness. So I can do two separate things, two options. I can increase the number of reinforced perimeters so that all this gap between the holes and the contour will be filled, or I can turn on reinforced infill. Let's turn on reinforced infill. So isogrid infill, 30% density, and here is the result. So now you can see that the holes are connected with fiber, with this grid infill, but the connection is also not very great because in this area I have plastic lines instead of composite lines because the area is too narrow. And if you will look at the material consumption, you have like 25 meters of fiber spent on this part. The better way is to use mask here. So if I have this hole fixed and this hole fixed and the load coming here, I can put the fiber on this trajectory so that this fiber will connect the fixed holes with the loaded hole by straight lines. So the fiber will work under tension, and that will be the most effective reinforcement scheme for this part. So we can make a mask like this. Let's apply such mask. And here is our mask. I'll apply it to the base model and we'll look at the result. So gray is our base model and yellow is our mask. And now I can turn off any reinforcement in the main model and I'll turn reinforced perimeters for the mask. And this way I will get the result like this. So as you can see, the loaded hole is now connected to the fixed holes by the fiber. And of course, I can make the number of perimeters inside the mask smaller to fit more fiber. Let's do it. I'll just set up all plastic perimeters outside and inside fiber to 0. And this way, I will have a more effective reinforcement scheme. So now the fiber goes around these holes and goes straight to the loaded hole. And I can fit, I think I can fit another one loop of fiber here, but I think you already understood the concept, the idea. Okay, so this is the first example. Let's go further. The next example that I want to show you is a solar battery panel. So it's much larger, as you can see, and I should switch from Composer A4 to Composer A3. And I'll move the part so it's inside the build plate. So the common way to reinforce this part is to use perimeters and infills, and then the result will look like this. So we will have perimeters going around the outer shell, and the internal volume will be filled with either grid infill, or I can use another grid infill as well. So this part should have bending stiffness and low weight. And if I'll look at the whole part, I'll see that it's a solid plate, and I have solid tops and bottoms over the whole area. But the weight of the part is quite large. If I'll calculate it, it will be more than 200 grams. So what can I do to reduce this weight? If I'll analyze the weight of our materials, I can make a conclusion that a lot of weight comes through this smooth PA plastic. That means that the most mass are coming not from composite material, but from plastic, namely the top and bottom plastic surfaces. But maybe I don't need these plastic surfaces to be in the whole area. So what's the purpose of this part? This part should be covered with solar elements like this, and these elements are glued to the surface of this base plate. And unfortunately, I can't get rid of top and bottom solid layers fully, because I need some flat surface to glue the solar elements. But if I'll make 3 stripes of solid material like this, I will be able to glue solar elements here and here. It will be reliable, and all other volume I can leave without solid shells. So this also can be obtained with masks. And in this case, we will use full masks. So let's open the second model with masks. So here we have model, but now it has 2 other models, 2 mask models. I will apply these models as masks to our base model, so I will have a picture like this. Next thing to do is to turn on reinforced perimeters for the base model, for the gray volume, and for the masks, for green and yellow mask, I will turn off reinforced perimeters. I will turn on reinforced infills. I'll use another grid infill with 20% fill density. And also I'll switch from internal mask to full mask. This way it will be, I can have 0 top and bottom solid layers. And as for the external shell, I'll set these numbers to 1, for example. Okay, so now we have our print prepared, and I'll press generate button. Okay, so first thing that I should mention is that the mass of the part is now about 100 grams, so twice less. And the print time is much lower as well. And let's look at the slicing result. So here is our structure. You can see that we have solid frame around this panel, and also we have solid rib in the middle, and we have just a grid, just composite lattice in these two large areas. And if I'll look at the internal structure of the part, I'll see that this frame and the middle rib are reinforced with perimeters. So this way we can have high strength and stiffness for this structure and low weight. Okay, so let's move further. I remind that I'll answer all the questions after I'll finish. So if you have any question, please write them to the chat. Okay, I'll create a new project and I'll show you a more complex example of mask. So it's quite complicated mask, but it's worth it. So as some of you know, we've made one example of plate with hole, and this plate was reinforced by fibers, and these fibers were following the trajectories of principal stresses. So the fibers went around the hole, and basically this part with such reinforcement can withstand much higher load than if you just reinforce it with straight lines. So previously that was already possible only with Nano-G code, and with Nano-G code you had to manually draw all fiber trajectories, and these trajectories after that were printed with Composer. So now you can do it in Aura. Basically we have two masks here, one mask for longitudinal fibers and one mask for transverse fibers. And these masks are, it's a quite, it may be quite complex structure. I'll show you a bit closer. So we have 12 layers in total here. And we have 10 layers for 0 degrees for longitudinal fibers and 2 layers for 90 degrees. And the masks are arranged so that the 0 degrees layers, which have higher priority, this mask has gaps, has 2 gaps. And in these gaps, we put 90 degrees fibers. So let's look at the result as well. So I need to tune it a bit. So the plate, which you've printed with Nano-G code, was fully filled with solid infill, and I'm going to have the same scheme here. So let's check all parameters. Lines 100%. Okay, 1 external shell perimeters, 0 plastic perimeters, 0 top and bottom solid layers, and after that we can press generate. Okay, so here is our result. And as you can see, fibers follow the contours of the masks, resulting in the same result as if I draw these trajectories by hand. And here is our 0 degrees layer. And if I'll go further, I can have a look at our 90 degrees layer or transverse fibers, and the resulting plate looks the same as the plate that you can see on our website in the cases. So it's the same plate, but now it's made in Aura in an automated manner. Okay, so let's move further from the masks, and I'll show you one example for support blockers and enforcers as well, and then on CLI. So let's go to support blockers and enforcers. So I'll open such a simple model. It's an overhang test, and if I'll select the profile and generate the code with the support structures, I'll see that the supports were automatically generated in this overhang area, and the zone for support generation was calculated automatically based on the overhang distance that you can specify in the profile. So you can change the settings, of course, but sometimes there is a need to get rid of some support structures or to add support structures in some specific places. So I can add another model, this rectangle model, and I'll make support blocker out of this model. I've moved it this way, so it will intersect with our part. And after that, I'll make it a mask for this overhang test model. So basically, the mechanics for support blockers and enforcers is the same. So I should make my model a mask. And after that, instead of full mask or internal mask, I can just select support blocker. And when I generate the code, the result will be the following. As I can see, there are no supports in the zone below the model when I had support blocker. And again, if I'll change this support blocker to an enforcer and look at the result, now it will be like this. So I have support structures generated in the whole area of this blocker, the whole volume of the blocker. So you can use it to customize the location of support structures. And priorities work for blockers and enforcers as well. So you can have multiple blockers and enforcers, and you can prioritize them. So you can have large blocker and some enforcers inside. This way you can like manually set up where the support structure will appear. Okay, so let's go to CLI now, and I'll show you one example. So for example, I want to slice this lever model. But I don't want to do it in Aura GUI. I want to do it from the command line, if I want to do it automatically, for example. So the first thing to do is to prepare all slicing settings, select printers, select materials, profiles, etc. And after that, I can go to the file menu and export session. So I exported session file, and if I look at this session file, I can see that it's a JSON file. I can format it. And if you look at this file, you'll see that it contains all settings, including printer settings, extruder settings, material settings, and profile settings as well. So all these settings may be used for slicing. And moreover, you can not only save the settings from Aura, but you can change them afterwards, and you can use your own scripts to tune the settings if you want. Now I'll open the command line here in this folder, and I'll slice this lever STL using these settings with Aura CLI. So here is my command line, and I'll run Aura CLI. So if you just run Aura CLI, you will get a help that allow you to see what options and what capabilities do you have here. So to slice the model, I will input the command Aura CLI, then I'll specify a models option, and here I will have a lever STL. I can have several models here as well. Then I'll use center flag. So with this center flag, I can automatically put the model at the center of the build plate. And then I'll specify session with the parameter session iOS JSON. And the last thing is to specify the output file, output lever G-code, and press enter. Then CLI will run, and it will slice the model and prepare the G-code and write it to the lever G-code file. So slicing is finished. And if I'll open this folder, here is a new file just generated. I can open it, and here is the code for this part. This is a simple option, but if you need to slice several parts, if you need to put them on the build plate on some specific positions, you can use not models option, but you can use input format for models in JSON. So if you'll open our documentation website, here you can find some advanced information about how to use CLI. So with this option, you can specify not only model, but some translations, rotations, scale of the part, and you can specify masks and layup structure for the layers as well. So it allows you to do the same, all the same that you can do in Aura in the graphic interface. So that's our CLI. And now let's go back to the presentation. I'll show you a few more examples of the mask usage. So if you want some numbers, here are the numbers. For example, for this wall bracket, here is another option of mask. So in this case, we've used another form of mask that will allow to withstand loads not only downwards, but upwards as well. And if you compare this design with the base design, you will see that the part deformations will be reduced by 8%, the part will be stronger by 7%, or if you want to retain the same deformations and stresses, then you can make part lighter by 12% and decrease the price, basically decrease the consumption of fiber and print time by 28%. The next case is a robotic leg. So this is a leg for a robot, and we've analyzed this part, and this analysis have shown us that there is a most loaded area in the center of this part between these fixtures, and you can apply specific reinforcement settings to this area. Basically, we can change the type of infill, and we can introduce additional perimeters along this contour. And this change will allow us to reduce the part deformation and stresses inside the part, or if you will have the same deformations or stresses, then the weight of the part will be reduced by 15% and the price of the part will be reduced by 25%. So the masks are really a powerful tool to increase your part quality, to reduce the cost of the part, and to reduce the print time, and to make your parts much more effective. Another one option is this hook. Another one example is this hook. So here we've performed a topology optimization of this hook, which is loaded by a vertical force. And after that, we've exported the volume as a result of this topology optimization, and we've used this volume as a mask. And we've reinforced this mask with the perimeters. So this way, you can place the fiber not everywhere, but only in the places that we need. So this part will be optimal in comparison to the base part when we will put fiber everywhere. So, and the last thing that I want to tell you is the licensing options. So currently Aura 2.0 has 3 editions: Neat, X edition, and Open edition. And premium license, premium features can be combined with any license. So basically a premium is a subscription that can be applied on top of your Aura license. Whether you have Neat license or Open license, you can apply premium features to it. The only exception is CLI. CLI currently is available only for Aura Open license. But masks and support blockers and enforcers are available for any edition of Aura. And if you have any questions about licensing scheme, or if you want to upgrade your license to a premium license, please contact your distributor and we will make it happen. So that was my information about our premium features, and now let's go to the questions. So I can see that Artyom Naumov have already answered some of your questions, but I'll look at them and elsewhere and non-answered questions, or maybe I will have something to add. Let's start from the beginning. So what about model positioning in CLI? So as I have showed, you can use JSON format to position your model. So you can specify translation, rotation, and scaling in this JSON file. So here is an example how this can be done. So you can specify file path and the transformation for this model, and another model with another transformation. Can you use more than one mask what happens if they overlap. Yes, you can use not only one, but several masks. And if masks are overlapping, the mask with the first priority will be the main. How do we get the license key of Aura? So if you've purchased a printer before the release of Aura 2.0, before the release of desktop Anisoprint, then you can contact your distributor to obtain legacy Aura license, which is the same as open Aura license. So, and if you purchased your printer after the release of desktop Anisoprint, then also your distributor should give you a key for the Aura editions that you've purchased, neat, X, or open. Okay, next one. Is it possible to place the masks one above other in that direction? Yes, it's possible. And moreover, in this edition, we've introduced that movement, so you can you can move your part not only in XY direction, but in Z direction as well. So for example, in this case, the part will be fully rested on the support structure. And you can move the mask in that direction as well. And previously, we've had another feature that allowed you to set different internal structure of the part for the different layers inside the part. So you were able to select different layers and set up a reinforcement scheme for these layers. And basically, masks are like a superset for this feature. So masks allow you to specify different settings, not only for different layers, but for different zones in plane as well. And another thing that I forgot to mention during my presentation, but I will mention it now, that if you have this reinforcement scheme layer by layer, then the mask will be turned off. And if you will add mask, this reinforcement scheme will be turned off as well. So you can use either masks or this layer by layer settings. But if you use masks, you can create the same effect with the masks as well. So yes, masks can be one above another in that direction. Okay, so can I control fiber angle for each layer? Yes, you can use it with masks or with this layer by layer structure. Okay, so is there a way to set and control loops forming in a mask, such as one shown with 3 holes for larger masks? For example, if I wanted overlapping loops going from one small hole each to the large hole, or would I have an approach such as creating each loop for itself as separate mask and following that head layers? Yes, the only approach here is to create several masks and to put these masks one above another in that direction. So you can have one mask going like this, another one mask going like this, and you can alternate these masks in that direction to achieve the desired layup. What is the fiber layer thickness? The fiber layer thickness is 0.36 millimeters for carbon fiber and 0.28 millimeters for the basalt fiber. So you can look at this value in the profile. If you have an open edition, then you can find it here in the profile. So I bought the A4 around 2 years ago. Is it possible to get a free license? Yes, of course. Please contact your distributor and you'll get a legacy license, which is basically a lifetime open license of Aura. So if I make a mask with a thickness of 1.7, 5 by 0.34, it would be 5 layers of reinforcement. Yes, exactly. It will be 5 layers of reinforcement. Why it shall not be possible to construct the parts completely in the CAD? Well, that's what you usually do. So you can construct the part completely in the CAD system. You can draw your masks in this CAD system as well, then save it as the single step file. And then you can open the step file and apply all the settings that you need to the mask models. So here's some discussion about the mask. Yeah, so that's what I've said. Basically, Konstantin Schubert said in this chat basically the same that I've said about this mask in that direction. So you can have several masks and go on in that direction and place several masks to have a reinforcement scheme that you need. Are these masks completely eliminating the need of Nanogy code? So, in my opinion, not completely, but of course, there are a lot of things that you can now do in Aura without the need of Nanogy code. So I can say that maybe 80% of your needs can be now fulfilled with masks. But of course, there are still some cases that you can't do with masks. And in this case, you can still use Nanogy code. And the main advantage of masks, of course, is that it's automated. So you don't need to draw all trajectories by hand. Aura will generate lattice infills, plastic entities automatically, and you just need to specify the contour in which you will lay the fiber. So please tell us the width of the masks in the bar with whole case study. Okay, let's look at this model again. I'll open this project again. So 1 square on the build plate is 10 millimeters. So the approximate width of this zones is about 3 millimeters in this section. And in the central section, I think it's maybe about 2 millimeters or maybe even less. So basically in this section, 2 fibers go through this mask and they are almost touching each other. So in this section, this volume is fully filled with fiber. So this masks basically they correspond to the reinforcement scheme that we had for this plate in Nanogy code. So you said that you were previously drawing fiber trajectories manually. How do you do that? So we have another tool, it's called Nanogy code. So basically it allows to convert CAD drawing in DVG format, in AutoCAD format, into the G code to print it on the Composer. If you are interested in this product, please write to support@anisoprint.com, and we'll send you the presentation and the further information about this tool and how it can be used. Will this feature allow user to use only CFC extruder printing without external shell? Not yet, but we are planning to introduce this in one of the following releases. So in one of the future versions, we will make it possible to set the number of external shell perimeters to 0, and this will allow you to print completely without fiber with composite only. What is the nozzle diameter? For plastic, standard Composer nozzle is 0.4, and for composite 0.9, as Artem already mentioned. What is the minimum space inside the external shell to lay the fiber? So Artem already answered this question. It's 0.65. But basically, if you want to make a perimeter, then you will need fiber to go in first direction and to return. So you will need twice 0.65, and it's 1.3 millimeters. What's the maximum file size Aura can handle? Well, that's a good question. I don't have an answer for this, but I think that mainly that's limited by the amount of memory that you have on your PC. And of course, the amount of time that you are ready to wait for slicing this model. But you can load a model that will cover A3 build plate fully, and it will slice it. Okay. So any possibilities for discontinuous fiber reinforcement? If you mean short fibers, then of course, basically the smooth PA is already a polyamide reinforced with chopped carbon fibers. So if you print with smooth PA and CFC, and then you have composite material with 2 matrix materials, even 3 matrix materials, and 2 types of reinforcement, continuous fibers and short fibers. So everything is possible here. I don't really see why someone would use CLI over Aura. Do you have any good use cases? Well, yes. We have some customers that use some scripts to generate the parts, and they use CLI after that to make G-code automatically. So if you have a lot of parts, then you can just automatically process them and then just put these G-codes and print them, and it will be even more I think good when you will be able to print not only from SD, but from remotely from server. Okay, next question. To make sure I understand 0.4 for plastic, 0.65 for fiber, and 0.9 for plastic and fiber combined. 0.4 is the width of plastic line, and 0.65 is the width for fiber line, and 0.9 is the nozzle diameter. How much does the premium license cost? So basically, the cost is 900 euros per year. It's a yearly subscription. And we have also discounts if you will purchase license for several years. So please contact your distributor for a full price list, and The distributor will also answer all your questions. Which format file support masking feature? Only step, not only step. You can use STL as well, but it's just for me just more convenient to use step, because when you draw your part, you usually draw it in some CAD program, and it's convenient to draw mask in the same CAD program as well. And so it's just convenient to save it as a step file, as you already use CAD. Okay, so I've skipped one question. Was the topology optimization conducted for isotropic material or including the fiber reinforcement anisotropic? That's a good question. Basically, this topology optimization was done for isotropic material. It was done in Fusion 360 from Autodesk, and like most topology optimization software, it allows only to optimize for isotropic material. But it's a good question, because if you subtract large amount of material, the result of this topology optimization will be like grid. And our experience shows that the result for isotropic material and result for anisotropic material will be very close. So if the remaining volume is a grid, then in this grid, all the ribs are working along this rib in tension, compression, bending, etc. And these ribs are not working in a perpendicular direction. So the result for anisotropic and isotropic topology optimization will be very close. Okay, so let's continue. Can default height be adjusted? What is the default layer height? Yes, if you have open edition of Aura, you can adjust layer height in profile, and you can adjust macro layer height for the fiber. And of course, you can adjust all other layer heights for plastic entities. But of course, you are not completely free in this layer height, because the layer height for fiber should be comparable with the diameter of fiber. So for carbon fiber, it's about 0.35 millimeters. So you can't have a layer height of 0.1. That will give you very bad printing results. But you can adjust the height. Was the topology optimization hook mask imported as an STL model? Yes, it was imported as an STL model. Question about CLI. Can I send my JSON and session file, I have premium license, to other people who have base versions of Aura, and then slice it with my JSON, etc., and generate G code? So the problem is that the CLI will work only if you have open edition, but when you have open edition and premium, you can slice anything with CLI. So you can send a file, they can make some changes and send it back to you, and you can slice with the settings. I don't see any problems here. Yes, you can generate G code this way. And basically that's the same as they will tell you what parameters do they want, and you will put these parameters into your profile and then slice. So can we add in more algorithm for Aura to optimize the location or trajectory of fiber reinforcement? Currently, this location can be specified by masks. So if your optimization algorithm will produce a volume like an STL format or in step format, then you can use this volume to control the fiber trajectories. So, and if you mean if you are going to have some algorithm to optimize the fiber locations, yes, we have that in our plans, but I should say that it's not a short-term plans, but we will do this eventually. Can positions and individual slicing settings of several masks also be set with CLI? Yes, of course. In JSON file, you can specify mask positions and settings for the masks. Can we have painting-like options to mask instead of using box or other model? So currently, you can only import a mask model that you have drawn in some CAD program. So if you can draw it in your favorite CAD software and then import into Aura. And unfortunately, currently, it's not possible to draw mask inside Aura. And I think the special CAD software will be much more convenient to use, and you will draw masks more easier there. But maybe sometime we will have such functionality built into Aura, but it's already not a short-term plan. Can Aura automatically detect which areas faces are weak, and it can strongly suggest to put fiber there according to the model position? Well, in theory, yes, that's possible. And as I already said, that's our plan for the long term. But currently, no, currently you can do it using some other software and draw a mask based on this information. How do you simulate the rectilinear path infill in an FEM software? So basically, you can use like two approaches. You can fill the internal volume with some grid, like with plates that will form grid, or you can use something like solid elements. And for the solid elements, you can apply some effective mechanical properties. So if you know the density and the directions of the ribs inside the infill, you can calculate, and of course, if you know the material properties, you can calculate the effective mechanical properties of such grid, including rectilinear infill or grid infill or isogrid infill. So basically for any type of infill, you can calculate. And we usually use the result of such calculation to apply this this properties to the finite element model. Can we change the composite nozzle diameter to use other different fiber types? So currently we have only one composite nozzle with a diameter of 0.9 millimeters. And currently we don't provide other diameters of composite nozzles. Can we use continuous glass fiber or Kevlar fiber? Well, you can't use glass fiber, but we have an analog of glass fiber. It's basalt fiber. So you can choose not only composite carbon fiber, but composite basalt fiber as well. And basalt fiber, it's pretty similar to the glass fiber, have similar mechanical properties, and the mechanical properties are even a bit higher for basalt fiber. And as for Kevlar fibers, we don't offer Kevlar fibers currently, but this may change in the future, so stay tuned. What is the minimum diameter that the machine can print? So do you mean minimum diameter of composite filament, or this another question from Arul Raj Vaidurayam. What is the minimum wall thickness that the machine can print? Well, if you mean plastic wall, it's like 0.4 millimeters. If you mean composite wall, it's two plastic walls, 0.8, and at least one composite wall, 0.65. So it's 0.8 plus 0.65, about 1.5 millimeters, but it's really a minimum amount, and the surface quality may be not very good with such settings. So if you want good surface quality, you will need to add some external shells. So the realistic wall thickness is about like 2 millimeters or a bit larger. And what is the minimum diameter? What is the minimum diameter hole that the machine can print? You mean the hole that is reinforced with fiber around this hole? So currently we have a restriction that the length of any fiber loop, of any fiber perimeters, should be larger than the cut distance, 45 millimeter. So basically the lowest length of the fiber circle is 45 millimeter, which gives us a diameter of 12 millimeters. But of course, you will have some plastic lines around the wall as well. So maybe around 5 millimeters hole will be okay to reinforce it with fiber around this hole. And if you have, if you will reinforce this hole together with outer contour like this, then there is no such restriction and the hole diameter can be any. Okay, so the next question. Can you please show any one of a hexagonal or honeycomb type core model in demo? So do you mean hexagonal or honeycomb plastic infill, or what do you mean? Because currently we don't have hexagonal or honeycomb plastic infill. We have triangular infill, grid infill, and basically line or zigzag infill. So no honeycombs. And if you mean like a sandwich structure, for example, if you have like several layers of fiber on top and on the bottom and some plastic cellular core, then of course you can, for example, let's use this part to show. I'll delete the masks and I'll, for example, to make it better, I'll scale this part in that direction. So now, for example, I can make a honeycomb like a classic sandwich structure. For example, I'll add a couple of zones. So from 0 to, for example, 2 millimeters, and another one, for example, from 9 millimeters to 11 millimeters. So here are our shells. And for this shell, I can use, for example, reinforced infill, like solid infill, 0 plus 60 minus 60. And here I'll turn on this solid infill as well. And for the rest of the part, I will have like sparse plastic infill. So I'll change it not for honeycomb, but for example, for triangles. And then I'll generate the code. So here are our results. So we have lower shell, fully filled with fiber. Then at the middle of the part, we have like core with plastic infill. And at the top, we also have reinforced shell. So it's something like this. Okay. So I think that's all questions. Maybe okay. So another one question I've missed, I think, is that cost per year per user or per printer? It's a cost per user, so per Aura license. So if you have Aura installed on one machine, that's a cost for this 1 Aura license, for 1 Aura key. So basically, if you already have Aura key, we can upgrade this key so it will have premium features. So it will be the same key, just with premium features. So if I've missed some other questions, or if you have other questions, please write to the chat. Otherwise, thank you very much for attending this webinar. And I hope to see you next time when we'll have more features to show. So thank you. Thank everybody, and goodbye. And if you have other questions afterwards, please don't hesitate and write to support@anisoprint.com. We'll be glad to help you, and we'll be glad to answer any of your question. Thank you. Bye.